Hello, Masa, can you hear me?
Hi, yes, I can hear you.
Okay, perfect. Are you the presenter of your paper?
Yes, I'm the presenter. I think I'm the first one. I mean, on the first paper.
Okay, perfect. If you want to try to share your screen or maybe some test
Yeah,
is
sure. So I just turn my camera on and then share a screen. And, and I think you can see it, right?
yes, I can see it.
So this is the tool, and also I have few pages slide for explanation to understand it. So then I think if I put this in, okay, I think it's working, right?
Yeah, it's okay. I
Yeah,
can see you perfect and I can
okay,
hear you perfect.
perfect.
This is the advantage to be the first one.
Yeah.
Now we have time and we ask all of you to be 20 minutes before because if you have any problem, it's better to have time to solve.
Sure.
Sorry, I didn't activate my screen.
Nice to meet you. Yeah.
Hi, Johannes, can you hear me?
Yeah. Hi.
Hi. Now we have time. If you can, I can hear you perfectly. If you can share your screen to make some tests or something, you can do it perfectly.
Okay. One moment. So. So I hope you can see this. Or should I make it bigger to some degree?
I think it's better if you can make it bigger a little bit, but we can see it.
Is this good enough to see something?
Yeah, it's okay. If it is okay for you, it's
Yeah.
perfect.
Okay. So
Okay, perfect.
if you can hear me clearly, then I don't need any more testing.
Perfect.
Thank you.
Thank you. Hi, Vladimir. Can you hear me?
Yes. Hello. Can you hear me as well?
Sorry?
Can you hear me well?
Now, yes, we can hear you. As I told you to other colleagues, if you can share your screen or make some tests, you can do it now because we have
Yeah, sure.
a few
Sure.
minutes.
No worries. Okay. Oh, but I cannot see it. Can you see my screen now?
Yes, we can see you.
Okay.
Okay, perfect. We are going to wait a pair of minutes for the chair and for the other assistant.
Sure.
Hi, Claudio, can you hear me? Hello.
Hello. Hi, Bedilia. Hi.
Okay, perfect.
All right. So it seems I'm experiencing exactly the same issue I had some time ago with, yes, yesterday with the other session. So I don't know what's going on and why it doesn't work, but
I don't know. We saw that you were connecting, but after that, you disappeared until now.
okay, right. So now I have to, so this is session, the third link,
This is
right?
room 3.
Number 3. So I'll try now with the fifth one. Thanks a lot for keying in.
Okay. Some participants are in the waiting room, but at 13:45, I'm going to open the access to the room, and the other participants have made some tests, sharing the screen and these kind of things. So if you can start at the time schedule, it's okay.
All right, I'm trying now to join the meeting from the other one too. Please wait, the session will start soon, it says, from session 5.
Okay. Okay, are you trying to enter to the other room now?
Yes.
Okay, tell them, maybe they can try to.
Yes, great. All right, perfect.
Okay, so I'm going to open the room, okay?
Okay, great. Thank you.
Bye.
Bye-bye. So, hey there. All right, so call over internet. Let's see if it's... Okay, great. So now it's working, I think. Am I on mute then? Perfect.
Can hear you, Claudio.
Yes, we are. So perfect. All right. So guys, we're now, I think you can hear me in 2 different rooms, which is exactly what we are aiming at this moment. So we are ready to start off the new, thanks a lot, Christina, for helping out there. Thanks also Bedilia on the other room. All right. So welcome to the demo session of BPM 2020. We're very happy to have you all here. You may have seen that we had to split the rooms a bit to let everyone be able to present their own demos, which is fairly much like what happens in the live sessions, in which we are considering the opportunity to jump from one side to another and watch at the same time, or actually not at the same time, but in a series, the different demos. So that's exactly what we do also in this setting, although it's virtual. If you're here, it means you have already had a look at the links and the presenters. So we can therefore start already with the first presenter. Let's see. All right. So we see you guys already ready to start off. And right, so I would leave the stage to you. Please, would you try if you can share your screen?
Yeah, I'm trying. So you should be able to see my screen, right?
Yes, the screen is visible. Perfect. So I would say let's start it off then.
Yeah, so perfect. Good afternoon, everyone. I'm Mahsa from Process and Data Science Group at Elweta Aachen University, and I'm glad to have this opportunity to propose and demo our tool. But before going to the tool, I just take a few minutes to talk about the system dynamic concept that we used in that tool. And this is the concept for simulation at an aggregated level. So usually in process mining area, we use the simulation techniques for discrete event simulation. Now we took another direction to have an aggregated simulation model. So system dynamics take the variables of a system and look at them in different period of time. And as you can see, these are two main diagram which are used in system dynamics technique. So just a quick example here is like we have the birth rate and we have population. So if you take a look at this system per year, so you can, by playing around in the with birth rate or death rate, you can have the population over next year. So this is the concept that we have used. And then you can see another model. So this is the basic stock flow diagram. And the value of stocks here, stock 1, is accumulative by flows, other variables, and outflows. So this is the main framework behind our process, behind our tool, which all the steps are implemented, and you will see them soon. So the main idea is that everyone is using somehow system dynamics in companies, and most of the things that are being used are like processes. So we had this idea that the data and processes and information from process mining are there, like events here. And then we can take a look at the processes or a specific part of the processes, like an organization or an activity in a specific step of time. So then we have like data which are perfectly fine for modeling system dynamics model and any further simulation that you want. So to just make it clear, these are some variables that you can see, and we can measure them out, on top of the event log, and comes up with this event log, which we call it SD log or system dynamic log or simulation log, which can be directly used for modeling. So I think we can jump into the demo directly. I will, yeah. Here you have the first screen, that a small description for all the tabs that we have, all the steps. So we start from here. I just prepared a very short, simple event log with the synthetic data to make it clear. This step is like any other step that you will see in any other process mining technique. So because we wanted that our approach and our tool work for every basic event log, we have just set the attribute for the event log, and then you can see basic information, and then directly follows graph. So if you look at this directly follows graph, this is a simple process, that process of call center. So we have the next call either rejecting because of the number of queue, 30 calls in the queue, accept call for driver, and accept call for request, and then further steps. So this was the basic information. Now, as I told you, we are going to distribute, to extract the data from an event log in the period of time. It is important to select this period of time good enough to have accurate simulation results. So in this step, we have just, if you go to output, this is the ready event log that just generated. We can test different step of time, and then like for general aspects of event log. That step is not always necessary. Sometimes you have domain knowledge and you know that your process is a daily process. So then you know that the best period of time is the daily process. We do some time series analysis and training ARIMA models to detect and suggest the best time window. Now the time window is suggested. Here we create that SD log that I explained before. So we start from the ready event log, and we pick, since it's a call center and the calls are coming hourly, we know that. We select a time window of 1 hour, and there exists several aspects. So for example, I select organizational aspects, and that will extract all the organization in the process, which here would be organization who handles the call for car or for driver or the systems, and then extract the variables out of each organization for you. Yeah, here you can see these are the three organizations that we had in the process model. So for instance, if we look at the still log or simulation log of the first organization, which are the tasks that is done by system, you can see some basic statistical information for some of the variables, like arrival rate per hour or finish rate per hour, or and so on. So you can see the closest distribution, which, for example, here normal distribution or Pareto, and so on. So, and also here, if you click and save the link, you can have the CSV file, which actually is a simple CSV file with the variable extracted over step times, which are 1 hour. Now we have our still logs ready, right? So it's time to find out the relationship between still logs. So if you can see, these are the still logs that we have, but I would continue with the general process to have more general aspects. So this is a still log generated for per 1 hour. And these are the relation detection, which is based on the correlation between variables over time and the nonlinear correlation. Here you can see some time shift window. If you want to see that, for example, there exists delay. If the arrival rate in the first hour goes up, then probably you can see that effect on the same period of time, right? And then it has like 3 time later it would appear. So if you want to test different window of time, you can set that into what difference between window of time you want to test the relationship between variables. This relationship will help us to later creating the conceptual model, and after that creating a stock flow diagram. So if you look at the correlation here, this is, as I told you, synthetic event log. And for example, if you look at the service time per case per hour, you can see that there is a exactly negative relationship between number of cases in the process per hour. This is why, because we generate the simulation data event log in a way that if the number of people in the process goes up, so the resources start to working a bit faster. So these negative correlation is being captured in per hour. Now, here you can see also, like for each variable, you can see different relation with other variable to make sure that either the relationships are nonlinear like here or linear, similarly like here. And this exists for all the variables in the extracted still logs. And now here it's time for the causal loop diagram or conceptual models. So for conceptual models, the strong relations are highlighted, but still the user has the option to select between the relationship that knows the best, because here it comes to the decision of the users. So I would say, for example, this is an example, that it's the finish rate is getting affected per hour by number of resources in the case and number of number of cases in the process. And like process active time, I just don't look, I try to be fast. Like here, and number of process like here. And then if you generate the causal loop diagram, you can see the causal loop diagram, which all the relationship, captured relationship by the data are like assigned here. So here, for example, you can see that the number of unique resources per hour has a positive relationship with the finish rate. So which is what exactly what we expected. So the model is like in the system dynamic model can be saved and played with on or improved if you want. So in the format of MDL, which is a public format of system dynamic simulation models. So this was the conceptual model. Now we have the conceptual model at the back end, and we want to do real simulation. So we need to have the stock flow diagram or the diagram that includes the numbers behind them. So to be able to do the simulation. So,
sorry to interrupt, Masa. We should go towards the end conclusion of the
presentation. So yeah, sorry.
No worries.
So it just take a few seconds, and then I just map them, create, and then here. And now we have this. I just want to do, so we had the still logs This is very end. So this is the STLOG that we use for creating the model. And if we go to the models format, I would use the model here. And if we do the simulation and validation, just a few seconds. I don't know why that's slow, maybe because of the Zoom. So now here, for example, we can see that this is the simulated data and the validation data for this variable. And this is the comparison of the distribution. So thank you for your attention, and sorry if it took more than it should.
So thank you very much. So questions from the audience? All right, so if there are none, I would like to ask if the, how to say, I read localhost. So have you already prepared a web service that is reachable from outside for enjoying this app?
Yeah, so it's actually on, the Docker file is on GitHub. So the whole app is like in GitHub with all the dependency, but also the Docker file. So if you install, just take the Docker file and run it as a Docker file, you will have the service. But in a public IP, not yet.
Masa, thank you very much for your presentation. I'm really interested on the integration between systems dynamics and process models. So have you considered the integration or identification on which activities correlate to which variables in your causal loop diagram, for instance?
Perfect.
So, yeah.
Thank you very much.
Yeah, thanks for the question. So yeah, it's
clearly, yes, thank you.
So if we go here, for example, the things that you mentioned, we consider it as like activity flow or activity or resource listed. So not directly as the part that you mentioned, but somehow we can have the variables, the aspect and focus of our simulation, system dynamic simulation, and extract all the variables that describe that activity. But then there is another research which exactly mapped the variables in system dynamic to the process model or PetriNet, which is like quite different from this part because we focus on the performance variables more. But to some extent, yeah, that could be done when you use the activity flows or list of activities. Then you have list of variables related to that activity or that set of activities, and then you can find out the relationship in the causal loop diagram.
Sorry, thank you very much. Thank you for your reply. Also, sorry for not muting the microphone before. I'm afraid I may have overspoken your presentation. Sorry about that. But thanks a lot. It was very nice presentation. So, however, I'm sorry, but I have to ask for the next presentation upcoming. I think it's Vladimir, right?
Yes, correct.
Perfect. So, stage is yours.
Thanks. I will share the screen. All right, now you should be able to see it. Can you see it?
Yes, perfectly. Thank you.
Okay. Yeah. So first of all, I would like to start with some introduction. Robotic process automation, RPA in short, receives more and more attention, and indeed, this is very powerful technology that allows business organizations to improve their processes by automating clerical non-value-adding tasks. However, the automation process itself is very slow because it requires a lot of manual effort. First of all, the routines that should be automated has to be identified by business analysts, and then they have to be implemented in the form of RPA script by RPA developers. Robidium, it is a tool that I'm going to talk about within the next 15 minutes. Is our tool to close this gap, to solve this issue, and we propose to record all the user interactions with information systems while completing the tasks into the user interface logs, and then to identify automatically the routines from these logs with their further compilation into RPA scripts. Now I will go to the use case that I will show how Rubidium actually works. So the typical task that can be automated is the task of transferring the data, for example, from the spreadsheet of Excel, like this, about student data, into the web form of the web-based application system. Here is a typical log that was produced by the action loggers, recording tools that we presented last year on the BPM demo. And we will use it for Rubidium to identify the routines. So first of all, you can upload the log. It is running an example in our case. And then you should specify the following parameters. The minimum support, in what percentage of traces should contain this routine. That's stated reasonably low to get as much routines as possible. Then the minimum coverage specifies which percentage of the log is covered by this routine. It is basically a balance between a routine length and routine frequency. So next, we can specify the mining algorithm. Let's keep it like that. And the selection matrix that specifies which routines should be prioritized. For example, you can select length or frequency of routine or cohesion score. Cohesion score is one of our preferred metrics, and in one of my research, we explained why. The next, our tool can deal with both segmented and unsegmented logs, but usually the UI logs produced by Action Logger are unsegmented. So we keep this checkbox unchecked and select the context attributes. We need to select the attributes that are used to distinguish between different UIs, between different events. Usually we select typical attributes such as a workbook name, sheet name, ID of the element, or its name, or inner text if it is some button in the web. We identify routines given this specified metrics. So first, the log is segmented, and then by applying the sequential mining techniques, we identify frequent routines. In our case, we identified 4 routines. By expanding the corresponding button, you can see what is the routine about. And now we can generate a script for one of the selected routines. Let's select routine 1. The script is generated, and it can be opened via UiPath, which is an RPA framework for developing of the RPA scripts. UiPath is a bit slow as is, but I just want to show you how does the script looks like. And the generated script can be then further improved and modified by the RPA developer. Here how How does it look like? The RPA developer can add some new actions if if the process changes, or modify existing ones. Finally, you can select which row of this student data you want to process. In the current version of the Rubidium tool, you can process only one row at a time, but this feature will go into our immediate list of improvements. For example, we want to process the row 2, which contains information about John Doe, student from Australia. You can execute the script. And it will automatically extract all the information that is required and apply the data transformation if the format of the input data has to be changed. As you can see, the script did fill in all the required fields in the form and submitted it. Now, let's try to see whether we can process some unseen behavior. Intentionally, I have recorded the log. Intentionally, the log records only first 30 entries. We can try to apply the script on the 31st. Although the values itself changed, they were unseen, the actual execution of the task remained the same, and therefore it was possible to process it as well. Here is also the structure of the Rubidium. I will go briefly through it, just to give you more understanding. Given the UI log, it serves as an input to the preprocessor component, which plays a role of the orchestrator and apply different modules when required. For example, if the log is unsegmented, it first executes segmenter to extract the segments, and then simplifies these segments. The simplifier removes the behaviors that do not affect the final outcome of the task in any way. For example, an example of redundant behavior is a double copying of a cell, for example, or filling in the field of the form with its rewritten. It is rewriting. Sorry.
Boris, sorry for interrupting, but we should go heading towards conclusion now.
Yeah. Sure. Of course. I just cannot track the time because. So just to summarize briefly, I think that this slide would be sufficient enough. Rubidium is an open source tool that can be used either locally or online. It is available on the following address, and it provides a functionality far beyond the record and replay, in comparison to most of the existing techniques, state of the art. Yeah, I think that can be a conclusion.
Thanks very much.
Yeah.
Good. Sorry, forgot to mention just that this setting is a bit different than the standard BPM research tracks and whatnot. So in this case, we are free to speak. So in case you have any questions, please feel free to turn on your microphone and ask your question or just write down your question in the chat. So in the meantime, I know that Andrea Marella wrote to me privately. So Andrea, the stage is yours, and then there is Yoon right after.
Okay, thanks for the presentation, also for the tool that is very, very interesting. And also the compatibility with AUIPAT is a plus, in my opinion, very good. I have a couple of questions, curiosities. So the first is about, maybe you said that, maybe I missed that. So when you generate a script starting from a routine, you are generating just the variant that you have discovered, right? Not other possible variants changing the data, right?
Yes, yes. At the moment, yes.
Okay, so one variant per time. Okay. And the other question is very technical.
Sure.
So with the logger, that is very interesting to have a logger like your logger. So what kind of application you can record? So which user action, what application you can record? Apart than Excel and Chrome, because I said here Excel and Chrome.
Yes, indeed. So, like, I could say that, like, if you had to choose between the applications that you want to cover, of course, you will select the most frequently used ones. And in our case, it was the Excel and Chrome. But of course, also you can record everything related to the clipboard. For example, if you copy or if you paste. But indeed, this is also in our future plans. I have to mention that the Rubidium itself and the logger are extremely connected, because while we want to cover one more application for Rubidium, we have to, of course, include it into the logger and vice versa. So, like, addition of one more application requires the modification of another tool. And of course, like at the moment, we are also focusing on the applications that can be automated via UiPath, because this is our target. And well, like, I think that in the foreseeable future, we will also cover other Office tools. Ideally, also maybe some work with PDF files, because they are also very widely used.
Okay. Thank you for the answer. Thank you.
Sure.
Right. So in the meantime, we see that there has been a parallel discussion also on the chat between Yoon and Marcello and Marlon, I see. So maybe, I don't know, like 2 or 3 minutes more to just illustrate, also Vladimir illustrate the powerful functionalities of pre-processing that were asked. So in particular, everything started with a question of Yoon asking if UI log pre-processing is part of Rubidium, and both Marcello and Marlon stated yes, of course it is. So maybe you may want to show a little bit again of this, and then in the meantime, I would already ask Johannes to get prepared.
Yeah, so first of all, you can see that since the logger has some limited functionality, for example, like the copy action inside Excel cannot be recorded. Like at the moment, we have these two actions: get cell, A2, and then copy of the keyboard action. However, two of these actions can be then merged into copy cell. I also here you can see the corresponding copy cell as one of the elements of the routine. Unfortunately, I'm not sure that I will be able to find right now the example of redundant actions here in the log right away, but the simplifier works in the form of redundant, like in the form of reduction rules. For example, if you find two read actions like copy cell without space in between, you just select, like you just keep the last one. Or for example, if you have two write actions without reading the previous content, you also remove the first write, unless it is unless it is a target of append action as well. Yeah, like I'm not sure I will be able to find it right here in the log, but the simplifier is like it is a component of Rubidium, and it does two things. First of all, it removes all system actions, like the actions related to clipboard, and it aggregates it with some actions that make sense inside, like with relation to some application. For example, copy cell or copy a value from a web field. And then it also removes redundancies by applying the reduction rules. I hope I answered the question.
Oh, definitely. Thanks a lot for illustrating all these functionalities. That's very, very, very interesting project indeed. Thank you. So I would then at this stage leave room for a bit of technical switch between the two presentations that follow one another. So now it should be the turn of Johannes Denschat with Pertunity.
Yes, thank you. I hope you can all see my screen.
Yes, it's clearly visible.
Okay. Then, first of all, yes, I'm Johannes Denschat. Together with Sophia Marmarides, I'm presenting to you our demo here for Pertunity, where we focus on sub-process modeling and hierarchy case management. And first of all, Pertunity is an adaptive case management system and was founded as an academic spin-off out of my PhD thesis. We focus both on structured and ad hoc activities, provide activity streams for transparency and traceability, and now we included sub-process modeling, which I present today. The ultimate goal of this approach is to have one system of record for all the parts of processes that today are typically scattered across many systems. And currently, these features I show to some degree work in progress. I'm only marketing them in 3 to 4 weeks when they're really finished. I'm hoping for feedback, so don't wait for questions or what you want to see until the Q&A session. Ask them as soon as you have them. And yeah, I also don't have all what I wanted to show already finished. The next few weeks you can see DCR graphs, Petri nets, and potentially more notations as well. I go into detail why this is important. So the basic idea that we tackle this is from the industry session, but the same image is good for here as well. In many processes you have in practice, for example, many medical quality management, you have both highly structured and regulated parts like this risk management involved for software development and updating medical device products, but also highly ad hoc activities. Here, these software development activities are merely an abstract task, but in practice, this is the main part of your process that doesn't happen in your BPM system typically. And what we introduce is sub-process modeling in this field to have flexible cases where all your context of your processes is happening, and sub-process instances that are automated for single aspects of this process. So you don't need to automate all of it, but only those parts that you know in advance. All those sub-processes are loosely isolated. They each have their own state, their own variable scope, but they communicate via the parent case scope. You can also have multiple instances per case. For example, if you are working on bug reports for automation, then you may have one case for all your bug reports of one product and start instances there and share all the context between those bug reports that are tied together or something. The approach of sub-process modeling allows that you have, for example, this basic model here on the right. You only look into a few questions you want to answer, do some basic automation with script tasks, generate a document, and that's it. That's kind of an aspect that an end user may be able to model him or herself. And if you only model aspects, the biggest advantage is that it doesn't really matter which notation you actually use for this aspect. So if you have a high variability for this one aspect where you're not so sure how to proceed, where planning is part of the work, you may go into the DCR or CMMN direction. And for stuff that is regulated and your auditor only knows BPMN, then you model it in BPMN. Also, since all the context is in the case, you can transparently deviate from structured processes, as all you need to do is create an artifact outside of the sub-process instance, but in the case, or create an ad hoc task or something. Okay, the next part that I'm showing in practice then is hierarchic data management. If you have hierarchies of cases, for example, for larger project management structures, then you also want to share attributes between them or attributes between the case and the sub-processes that are performed within this. For that, we have arbitrary master data where you put attributes as you wish with the entity attribute value schema, and also data objects as you need them, user-defined data objects where you put in all the attributes you need. You have an identifier to use them, and you can generate them in processes or use them as parameters. And for the dependencies we saw, we have found a matrix of 4 different types where you define these dependencies either in the parent or the child, and what type of dependencies you define. So for example, inheritance isn't the best word for it, but if you get an attribute, a project ID down to your single sub-processes, then this could be called inheritance, or at least you know it from this domain. And if you want to see all your subtasks, you may aggregate them in your parent case. So this is the basic idea, and now I dive in a little bit deeper. Here you see a basic case hierarchy, also the example I had in the video. And if you want to start something new, for example, a research project or something, then you just create a new case. And feel free to say your tasks or your problems you want to see, because then I will tell it a little bit to you. So first of all, we start with a new case. Now we have an empty one, and we see that we have different types of artifacts involved. For example, wait a minute. For example, context, which is still a little bit empty now. For example, here, let's put in a programmer. This could be me. We can have as many ad hoc tasks as we wish, or we can also start with some sort of process template we may have created for this type of things. These processes you see on the left side, each has their own state. This one is running now. You have some tasks that can be performed directly here, and some of those tasks are also tied into the Kanban board. You may see them here. And let's start with gathering some basic information I need for this type of project. For example, something. So now we have something here. And we pick some sort of stakeholder or create one if you wish. Let's pick Sophia. And we have these variables now in our scope. We may change them here, or we may use them later. And also another task we can perform right here is just one that should be documented that I did it. in this case, there's no form or something involved. We will get these types of tasks a little more sophisticated in the future, where you put Markdown in it, so, just to guide through regulation, and now we perform it like that. The process is still running because 3 of those tasks are tied into the flexible tasks. And just let me finish them. Then you can also see that the process is now finished, and that all those tasks are visible in this activity stream, and that that you have successfully performed this. This would be the first type. You can create an arbitrary amount of these. Let's pick second one just for fun. And we can also create multiple instances of that, regardless of how bad this one process is. We can also create arbitrary stuff in here. Let's pick some sort. Yeah, this one is good. So this is more or less project management to some degree, and also all the groupware artifacts you typically expect of such a system if you expect groupware, not BPM. So now the next one I can show you is data objects. First of all, you can start with an empty data object that doesn't really do anything. You give it some attribute value you need. And for each artifact we have, you also have these attribute values. So for example, if you need some sort of indicator for how long you took, and you don't have a time management tracking somewhere else, you can just say hours or something and put this data you have somewhere right at the artifact where it belongs to. Can also connect different artifacts. For example, if it's if this document would be related to this task, you can just say that it is, or you can also connect it to certain stakeholders, or basically any type of artifact you see in our solution, which is highly different to the situation where you have 5 or 6 different BPM systems that are not connected together, that are more or less connected by the nodes you may add. So what you also see is that this task has some activities now that are documented on it that other tasks have as well. You have this on the granularity of each case, where you can add whatever you need, and you also have this on the granularity of all your cases. If we change another one, you may see them here in the timeline as well. And what we can also do is for structured processes, for structured data objects, that we add them form-based as well. I only have one example now. This one you saw in the process, you can also do yourself by just adding something or whatever. And if you have it that way, that's where I messed up. This is 388. That you can also have them in some sort of tabular schema. I'm working on different views as well. So this would be all data objects that were created for this case. You can also in this view add new data objects, but only the structured one that are particular for this type of data schema. For each schema, you can create them yourself. This looks like that. You add attributes for each one. You can create new data schemas as you need, but this here is highly prototypical. So don't ask me in the Q&A about this one. If you ask me in a week, I can show you everything around that. So the last thing I don't have in the video is that we focus a lot on low code. So each and every stakeholder can create basic process models themselves. You just add something here in the Camunda modeler. We are working on DCR graphs and Petri nets as well with the same modeler. what's still missing, and what actually made me took so long is that we want to have each model multilingual, which Camunda Modeler for now cannot do itself. So we're extending that, but we also want a feature for all the other modeling notations. And you just create basic models that might only be useful for coordination here in this case, and directly perform them in your new case. So you don't have a really deploy process for that. If you put some web services in it, it will take longer than that. But for now, we have this process instance, and it already works without doing anything. The other stuff we do for low code is that you can have arbitrary Word documents or Word templates, which are basically very simple programming language that is visual. We also apply them in the process models as well. So variable transformations and so on, and actually end users can cope with that type of programming, at least what we saw from it. So I'd be happy to answer many questions of you, or do an example case of what you want to see for now.
Thanks very much for your presentation. Indeed, it looks really like we are having a glimpse on a large project. So yes, there are many open points. So anyone from the audience who wants to intervene? Just like before, please pick up your microphone and speak freely, or write down in the chat if you can't have the microphone up. All right, so if there aren't interventions from the audience, I would ask one question exactly on the very last thing that I saw, because I mean, out of experience, we can say that many of the workflow management tools tend to have pain points in the connection between automation of scripts and the how to say, the execution of the process. So I just wanted to know, how did you manage to connect, for instance, which language do you support? Like if there is a specific language for automated scripts, or do you support a specific one like Drules or JavaScript or anything? And also if there is any way to connect already existing modules from other services directly to Opportunity.
So yes, the basic idea to do just that. What we do is this language here is made up one, where you program in paragraphs and text. We just apply them as automation you import as an attribute in these activities. So you just attach this information that you use this template for that. And for the script tasks, we currently only support basic variable transformations and plan to add support for arbitrary VSDL web service calls. So this is not that much working for now, but we are going in this direction. We don't offer support for JavaScript or Drules or something, because the type of target audience we have is mostly small and mid-sized companies that are in regulated domains, where most of those activities currently revolve around how to document stuff. And for the automation part, we offer external APIs where you tie your own forms of your website or of your product into the process management system, and also to get status, but the programming you want to do as a cloud service, you have to do externally. So yes, this will trigger your external program you have somewhere else, and that way it's more scalable, at least for the current approach we have. Does it answer your question, or?
Yeah, totally. I think that the next step would be to start trying the application out. So, I mean, do you already have a program for academic licenses, by the way?
What? I didn't get it.
Sorry, like a program for academic licenses. So like in order to let the users from academia, for instance, try out Opportunity with their own, like the students and teamworks.
Actually, I planned to finish until today, but it didn't go so well. For all participants, we have those professional accounts. Just write in the notes that you were attending this conference. In a few weeks, we will have this academic part on the website. It's not yet there. You don't have to pay for trying it out. Or just email me. We will have that in the very near future, but it's during Corona, you know how project management and timetables went this year.
Thanks very much. So a big applause to you from the audience and of course from all of us. So although it's not, it can be heard that, loudly. So I would say now the second round of the presentations is about to start. So for the moment, I would suggest to get a glass of water, everyone. In the meantime, so we would essentially restart. So Maza, are you there already?
Yes, yeah.
Lovely. So maybe while we get a glass of water, if you want already to share the screen, so that we anyone who's connecting already sees that there is something about to start, and it's, you know, to foster curiosity.
Yeah.
All right, fantastic. Thank you very much. By the way, it's Maza, right? I didn't mispronounce.
Yeah, it's correct. No, it's definitely better than German pronunciation.
Okay. Okay. Good. So let's take 5 minutes and off we go. I mean, we don't start sooner just to allow everyone in case to, you know, drop by and finish the first rounds and maybe the other sessions which are parallel. All right, so I'm now speaking at the same time in 2 different channels for the sake of, for clarity. That's why I'm now suggesting all to get ready for the next presentations. We have on channel 3 the presentation of PMSD from data-driven simulation using system dynamics and process mining from Mahza, and on channel 5, on channel 5, instead, we have Thomas from Celonis for the presentation of dynamic pattern-based case filters using regular expressions. So just to remind the rules of the game, in this case, we are attending a session which is highly interactive. So that's why we don't have a usual system for raising the hand and getting the questions moderated. We like a rather interactive setting. Therefore, if you have any questions, please write directly them in the chat, or in case, just wait for the end of the presentations and speak out loud. Take your microphone. There is free access for that. So the presenters have at their disposal 10-12 minutes to present. Then the rest is basically Q&A. So please do not hesitate to. Don't be shy. They're here for you. And yes, so I'd say we're 1 minute in advance. I see that both Mahza and Thomas are both ready. Sorry, I'm looking now at multiple screens at the same time. That's why I'm switching around. So 14:45, stage is yours, guys.
Okay, thank you. So again, hello everyone, I'm Mahza, and then I will take a few minutes to just discuss the main idea behind our tool and also the concept of system dynamics to make the tool usage clear. So system dynamics modeling is the type of modeling that you can look at the system over a period of time, and then during this period of time, you can capture the variables and describe and simulate the system over this period of time. So, very simple example of system dynamics you can see here. Just take a year as a period of time, then you have these birth rate and death rate, so you can control those, and then controlling them over a period of time will let you to have these periodic simulation and finding about the population. These 2 types of these diagrams are the most important diagram in system dynamic modeling techniques. And then this one is a stock flow diagram, and this one is mainly for conceptual modeling, which this one includes the equation behind the conceptual models. So as I told you, is a type of modeling in simulation, like you are able to do these simulation in an at an aggregated level, and this will help you to play with one variable and see the effects on other variable over a step of time. So the main framework behind our tools is like we have this pre-processing, model creation, and we do the simulation and validation as well. And at the end, you can play more with the tool and have the more complicated simulation model, which is based on a valid simulation model. If I want to put it in a simple word, so we have this, in the process mining, we have this level of events, like gradually we have event 1 until event n. And then we've been thinking that why not we don't look at the processes over a step of time. We define several variables, and then we capture these variables and value of these variables over the step of time. So very simple explanation and example would be like here. You have set of variables, and then you have the variables here and the values over a step of time, which can be day, hour, anything based on your process model. So let's jump to the demo. Yeah, here, this is the first page that which you can get, and the code is on GitHub. You can easily access or run the Docker file. Like any other process mining tool, we use just first to map the basic attribute of the event log. So here, we map the basic attribute that we expect any event log has one. After setting the variables, it shows the basic information and also a discover the directly follows graph, which shows you what is your process and then helps you to design the model later. In this step, as I told you, our plan is to have these variables over a step of time. So the time is very important. Either you know the time, you have background knowledge, you know the process is daily, hourly or so on, or you don't have it. So this step helps you to test the time window. Oops, sorry, I did didn't select the event. Yeah, this step helps you to test your time window, and then after having these ARIMA models and time series analysis, it get back to you with the best recommendation for time window, as you can see. Now you have the time window, like we here select this, and you have your event log, which is the attributes already there. So you can use one of these aspects that in which level you want to do the simulation, and then you generate this part generates for you the SD logs, which directly use as a data in your simulation model. So here we chose organizational level. So you will see the different organization that's there. Like in our synthetic data, there exists 3 organizations. So I just, for example, select the first one, and then here you can see different variables over 1 hour, which is our selected time window, and the distribution, the closest distribution to those, and also other attributes that you can find out for the variables. Here, the relation detection parts help you. For example, here, if you look at the general process for 1 hour, helps you to discover the relationship between variables that you extracted. We also have here time window shift, which, for instance, if some of the variables has changed right now, and the effect would be later on appear on the other variables. So if you want to test that, for example, arrival rate here, at the first time window goes up, then the effects in third time windows would be appeared on the waiting time, for instance. So this option, this part gives you the option to test also the variables and the relation between variables them. So if you look at the variables, for instance, here's the relationship between variables that we had for 1 hour in our data set there. And you can see that, for example, here we have for service time and also number of cases in the process, we have the negative correlation, which is how we design our event log, and it captured the relationship in hourly manner. The next step is that we can take a look at the relationship for each of these variables.
Sorry, Masha, but we have problems with your sound. Can you repeat the last, please?
Okay.
I don't know if only I have the problem, but I can hear you well.
No, unfortunately, there seems to be a connection issue. Maybe we can try save bandwidth by switching off the camera. Sorry, Masa, for asking this, but
Sorry, guys.
hi, here you are again. Hello.
Yeah, okay, yeah, I think something went wrong, right?
Yes,
I
there has been a blackout for a few seconds. Now we're happy to see you here again with us. So
yeah, so sorry for that. I will just go back and try to catch on so fast. So I hope that works this time. So you can see the screen now.
yes, perfectly.
Okay,
Thank you.
then, yeah, this step helps us to have the relationship between the variables separately, and then we go to create these conceptual models. And for the conceptual modeling, you can see the relationship which are strong highlighted, and here is the part of the part that user has to interpret and then select one of these attributes and like relationships to have the further, like, so I will just do it for just a couple of them to show how it works randomly. And this is the I think something because of the Zoom is like a bit. So this is the created conceptual model here, and you can see the relationship on top of each arcs and the type of the relationship, which the effects are negative or positive. And also you can download the created model in the MDL format as well. So the second part is to have these relationships in the form of stock flow diagrams, which are the diagrams that we can do actual simulation. So the stocks are the number of cases in the process per hour, and the inflows, the flows that per hour add to the stocks are arrival rate, and the flows that remove from the stock, the number of cases in the process, are finish rate. So if we create this, and then we can see based on the relationship, so it's not the complete one, but still you can have the MDL file, which you can use in any system dynamics modeling if you want as well. Then the last part is to have the generated STLOG. This is the STLOG that we use for our relation detection, and the generated models, which I prepared the model which has some equation. And so if we apply these two together, the simulation automatically will be running over steps of time, which are hourly right now. And then a pairwise comparison between the real values and the simulation are done for the variables. For instance, we can see for the finish rate, like these values are for simulation and for real values, and also the distribution. And if you want to see after this step, you have the options for extending your models. As you can see, this is the model for BPI Challenge 2012 that the basic models are created based on the software, and then other variables are added to that. So here you can see that here we have, for example, this variable we add the desired number of finish case per day, and then we can play with that and see how many more unique resources we need. So this is actually the final goals that you can reach after playing around with the tool, having the basic valid model, and then you can add and insert further variables that you want to have a complete simulation model and play out your scenarios. So thank you for your attention, and I'm willing to answer your question.
Thank you very much.
Sure.
Indeed. So any interventions from the audience? Well, if there aren't, I would gladly ask a question about the future of this project. So are you currently planning to run evaluations with users to see what can be the interaction patterns for the usage of the tool, or rather extending the tool towards new features, or both?
Yeah, exactly. Actually, as you said, both of them, but mainly we are going to have this extension for the automatic equation detection. So as I told you, many times in this part of modeling, we need the user to interact with the tool, and we want to make this part more intelligent. So yeah, the main focus will be to more intelligently discover the equation and model, and less interaction with the user. And also for the part that we have this relation detection, we are planning to have some user tests to see how it can improve the understandability of the steps and their connection. So if there is no other question, I can stop sharing.
Thank you very much.
Yeah.
So, well, great. Thanks a lot. That was a very interesting one. And yeah, looking forward to the next demo for BPM 2021. Why not, right?
Thanks.
Great. So let's see. Let's have a look at the schedule. We should have then the next presentation from Volodymyr again. However, in order to keep the presentation synchronized, that would be nice also to see if the timetable is respected. So we should start at 15:05.
Okay.
We have still quite some time to adapt.
All right.
Right, so Vladimir, maybe you may want to already share the splash screen for the next people entering. So if you share your screen, I will already dictate what's gonna, yes, what is gonna happen here. Great. Right, so while we wait for the next session to start, for the people who are already attending the session, waiting for 15:05 to start the next round, the next presentation, let me recall that we are already offering not only the recorded videos of the tools, but also the authors were so great not only to record the videos, but also to provide tutorials, and also the papers are already published on KWS proceedings. In the proceedings, you can find the papers, and all the papers have the links to the additional material. So in case you're more curious about the tools, or maybe you have missed some presentations already, well, you can still look up what the authors had for you. So again, a big applause to all the authors for their incredible effort to produce all this material. That's really not so trivial to it all. So thank you, guys. And right, so getting closer to 15:05, and then we can start the next presentation. Let me also thank the presenters thus far, who has been incredibly timely. So they had 10 to 12 minutes at their disposal. They used it all and not a minute more. So despite the great interest that the tools that they have have been presented this far raise in the attendees, sorry, in the audience. All right, so it's 15:04 in Central European time zone. We are happy to have on channel 3 Volodymyr Leno for the presentation of Rubidium, automated synthesis of robotic process automation scripts using UI logs. And on channel 5, we have Caroline Winter presenting RegMiner, taming the complexity of regulatory documents for digitalized compliance management. So our presenters are already connected, ready to start. Thank you guys for being here with us. And yes, so as well, let me remind again, whoever wants to intervene, just please feel free to type down your questions in the chat, or in case towards the end of the presentation, feel free to just speak out loud to let the presentations be highly interactive. So Volodymyr, Caroline, thank you very much. The stage is yours.
Okay. Hello, everyone. First of all, I would like to start from the introduction. Robotic process automation allows business organizations to automate the clerical tasks within their processes. This is achieved by implementing and then executing software scripts, also known as RPA bots. However, the automation process is very time consuming because it requires a lot of manual effort. The routines to be automated has to be identified by the business analyst first, and then they have to be coded in the form of RPA scripts by the RPA developers. Rubidium, the tool that we are going to present right now, is the tool that allows to automate these manual steps. And briefly speaking, to automate the process of automation. First, it identifies the candidate routines from the user interface logs that contain the execution of such tasks, and then compiles them in the form of RPA scripts. I'm going to talk about the architecture of the tool now, and then I will jump into the actual demo. So the Rubidium consists of 6 components, as you can see, 6 modules, and 4 major components. Given the UI log, Rubidium first preprocesses it, and preprocessor component plays the role of the orchestrator, which applies the required modules when needed. For example, if the UI log is unsegmented, it first applies a segmenter to identify the segments that represent each individual task, and then it simplifies these segments by removing the redundant behavior, the actions that do not affect the outcome of the task. After the log is preprocessed, it is given as an input to routine extractor that identifies the candidate routines for automation by applying sequence mining techniques. Each candidate is then evaluated on the subject of being automated, of being automatable, and for each automatable routine, the routine specification is discovered. Such routine specification discovers all the data conditions that are present in the routine, all the data transformations that are involved, and it specifies the structure of the execution of this routine. Finally, this routine specification is given to compiler that produces the RPA script by mapping each corresponding action of the routine specification into the corresponding executable command of the selected RPA framework language. A typical task that can be automated is the task of transferring the data from one application to another. For example, from a spreadsheet of an Excel application into the form of web-based system. A typical log that was recorded by executing this task is the following. It was captured by the action logger, the tool that we presented last year in the VPM demo. Let's load this. Let's load this log first. And then specify the input parameters. First of all, we have to specify the minimum support. How many traces this routine has to be observed. Then the minimum coverage. What percentage of the log the routine covers? Then we have to select the mining algorithm to discover the candidate routines, and the selection metric that specify which routines are preferable for us. For example, we can select the length or frequency of routine, or coverage. Let's select cohesion for this example. Our tool can work with both segmented and unsegmented logs. For example, one may use alternative technique for segmentation and then use the segmented log for as an input for Rubidium. Usually, all the logs that are recorded by the action logger are unsegmented because you record all the actions as a one sequence. Finally, you have to specify the context attributes that are used to differentiate, that are used to distinguish between different actions and to group the same actions across different traces. Usually, one selects target application of the action, the workbook and sheet name, if the action occurred in Excel, ID or name or inner text if it was observed in the web. Now we are mining for the candidate routines, and these routines will be already considered to be automatable. As you can see, we have found 4 variants of routine. You can check the details of this of each candidate by expanding the corresponding button. Let's automate the first routine. For the sake of time, I have already opened the same script in UiPath. UiPath is an RPA framework that is often used to develop the RPA scripts. However, in traditional settings, the RPA developer has to build a script by himself. The generated script correspondingly can be further improved or modified if the system change occurred. And finally, the script also takes the input parameters, which is in our case the entry of the Excel spreadsheet that you want to process. I will show you the Excel spreadsheet with the student data, which was used for this use case. Let's decide to apply the script for the second entry. As you can see, the RPA bot automatically extracts all the required information and applies the data transformation on the fields if necessary. Finally, after it filled in the form, it submits. By contrast to the existing RPA techniques that provide the record and replay functionality, our tool allows to process unseen data. In this example, I intentionally recorded first 30 entries of this spreadsheet. Let's process the 31st one. For this, you should change the row argument and click on the play button again. Although the data values have changed, the structure of the task still remains the same. Hence, the RPA script could process the unseen entry. Rubidium is an open source tool that is available online, and it is accessible at the following address. It also can be installed locally, and the instructions and the setup instructions are available in the corresponding GitHub. You can find it in the paper. Thanks for the attention. I think I'm done. If you have any questions, I'm happy to answer. Claudia?
Right. So, well, let's see. I left some room for the self-organization, but if there are no further questions, I'm sure that some would come because of the width and vast, like, impressive amount of work in this project. Yeah, I have one question in this case regarding the utilization patterns. So, have you noticed certain, let's say, analysis that have been, like, from the analysis you have conducted with the tool, have you found any user behavior patterns in the usage of the tool, and then of course also in the data entry that you've been analyzing this far, like things that are recurring the most, like most often?
Well, yes, indeed. Like, first of all, this log that was recorded, it contains mostly the routine execution, but we also tried to use it on the, let's say, real, like very real life logs, because also these ones are real. Like whiles, and we conducted we cooperated with the University Service Improvement Team of the University of Melbourne, and the team inside the university that manages scholarship applications. So basically, we installed the action logger and recorded their daily behavior. And from the obtained logs, we were able to identify the actual routines, and it was confirmed by them that yes, these tasks are performed frequently, and indeed some of them are already automated by the team that is running also under the University of Melbourne.
Understood.
I'm not sure as I answered your question. Maybe I didn't understand it.
No. It basically, that was the main curiosity that I had. So how about like the testing with the users and also from the data you have been passing? And yeah, just to switch to something, of course, unless the audience have further questions, they have the absolute priority anytime, of course. Well, something a bit technical. So
Sure.
have you found any hurdles in like intercepting the data stemming from different applications? So were there some more complex ones to extract data from, some were instead like already well-defined for standards, for destructions?
Yes. Yes, thanks for the question. It is very good question because, because of course, like the action logger assumes the things to be in certain form. Like for example, the classical organization of the web sites, like the same classes for the elements. Sometimes, however, the organizations tend to use their own custom created websites with very, very unpredictable names for button, for example. So sometimes it is very, very difficult to detect whether you clicked on the button or whether you clicked on the field, or whether you whether your click is meaningful, because traditional action logger tries to capture only the clicks that are meaningful. For example, if you click on button, it's recorded, but when you click on some like on the background of a website, it's not captured because, it wasn't important. But sometimes this information is very difficult to obtain because of how people tend to organize things.
Yeah, right. So it's very much into personal data management in this case, like personal, so to speak, personal from the organization perspective.
Indeed, and it makes us to apply some customization to the recording tool, because otherwise, you can, ideally you want to make all the logs in the same form, in some standard. So you can then apply the same technique on different logs. but sometimes it's very tricky
I understand.
because of these aforementioned things.
Can I make a question? Oh,
I
sorry,
see there
sorry,
is a
Claudio.
question from Vil, if Q stands for question.
Yeah.
Great.
Yes.
So perhaps to follow up on Claudio's, let's say, question, there are now several, let's say, commercial players focusing on precisely this problem. So one of my former postdocs, JC Bose, is working for a company, Scan. And then I recently saw a demo, and they are doing, let's say, image analysis. They are doing text mining. They are using all kinds of AI techniques directly on the screen image, rather than somehow that you expect the information to be in a structured form. Did you compare it with such tools? And perhaps, let's say, a bit of a strange question would be, is the academic world able to compete with the commercial world when it comes to these types of things?
Well, first of all, like usually, I cannot say that academic world can compete because usually this are done as like in the form of small projects done by 1, maximum 2 people. For example, like the Rubidium was implemented by 2 people. Usually, enterprise companies have whole teams working on this thing. So of course they can pay much more attention and effort and resources to make it better.
But I don't mean it so much in terms of manpower. What I have the feeling is that many of the problems are really engineering problems. That if a company is running Office products, it's running, I don't know, let's say all kinds of web applications.
Yeah, I got it.
It is using, I don't know, ancient software, etc. I think for each of them, it's like more an engineering problem.
True. Yes, I agree with that statement. And indeed, I think that the best logger should combine both image recognition techniques plus, if possible, this like web scraping, identification of the data already available, and in this way it will be like the results will be much better quality. And related to this philosophical question, I think, well, like of course this is mostly an engineering problem. Of course, there are some algorithms behind the applications, but I think that like for the modern world, like it is enough to have something simple than to have something very, very, very well crafted. So,
okay.
Yeah.
Oh, thank you.
Thank you very much. Sorry, there was a question we can ask like in a 2-3 minutes question. In the meantime, I would already ask the next presenter to get ready. Sorry, another question came from the audience. Thank you.
Hi, thank you for the presentation. Hi, Claudio. I was wondering, what are the sorts of routine are you able to automatize other than data entry? Like copy and paste around, I don't know, scrolling on Facebook.
Well, so of course it is limited by the range of applications that are covered. And at the moment we are covering a web, like a Google Chrome and Excel. So everything that is performed either solely on one application or across them, we can capture such routines. We can then automate them via UiPath. Additionally, we plan to cover more applications to increase the coverage and the applicability of our tool. But well, like yes, everything that was done in the web and Excel can be identified and automated. All such kind of routines.
Okay, so some things like, I don't know, uploading files or other sorts of stuff is not yet supported.
Not yet, yes, not yet.
Okay, thank you.
But of course, well, this is our one of our targets.
Yeah,
so
looking
that's
forward
very
to
interesting.
sorry, yes, I was looking forward to the future work then. Sorry, Williams, for
don't worry, don't worry.
Great. So just for the sake of time, now it's the turn for the next presentation. I think Johannes is already ready to start. It's 15:25 sharp, so really the floor is yours. Thanks again for all the presenters, and thank you also to you for the questions this far. Looking forward to the closing demo of this session. Please.
Thank you. First of all, I'm Johannes Tenschert. Together with Sofia Marmaridis, I'm presenting to you this demo paper. Pertunity is an adaptive case management system that was founded as an academic spin-off out of my PhD thesis. We focus on structured and ad hoc activities, provide activity streams for transparency and traceability, and now we included sub-process modeling that we're presenting today. The ultimate goal is to have one system of record for all the parts of the process that today are typically scattered across many process and information systems. And since the first demo, I also learned a little bit more about time management. We have more content in the second demo now, where I present two features that were missing in the first one. The features I show are still highly prototypical. In 2 to 3 weeks, I want to finish them up for marketing. So if you have feedback, feel free to just say so during the presentation. And I need your feedback, so give me lots of it. Yes. Then one question prior to that was, will there be academic licenses? Yes, there will. If you want them now, send me an email and you will get it. You don't need to pay for academic licenses. And in also 2 to 3 weeks, we will have that on the website and a good process for it. So let's dive into one actual process. This example was from the industry session where I had the same one for medical quality management. And in this process, you see software development and risk management activities involved in order to update an already existing medical device product. So software development for making it better. If you look close into this process, you see that the risk analysis, assessment of total risk part, and risk management reports are highly structured. These parts are regulated, and that the whole process also looks very structured. In reality, the biggest part of this process is software development activities, which is merely an abstract task, which also, in my opinion, is a very bad idea, because this abstract task will not happen within the BPM system, not happen in this context where it belongs. So what you also see, even though this process looks highly structured, you have both very structured and very flexible parts within the same process, within the same context. And what we try to achieve is to have both paradigms within the same system of record. So we apply two approaches for that. The first one would be sub-process modeling, and the second hierarchy case management, which I dive deeper a little bit later. For sub-process modeling, we had the basic idea that you don't model the whole process. If you already know in advance that some aspects of that will be flexible, some will be different variants, and for some processes, you don't even know which path they will take, because planning is part of the work. But all of those sub-processes you have, those have the shared context of the parent case, the parent project, and so on. All those process instances are loosely isolated. Each has its own state, like it's typically its own variable scope, and communication is not the typical parameters you give them by beginning or taking the end state, but you can also communicate via the shared case parent scope, so the attributes of the case. You can have multiple instances per case. For example, if you model the process of bug reports, this way you have one parent case for all the bug reports of one product, and those child bug reports can also be related to different artifacts or related between them. If you have only modeling for aspects instead of the whole process, you don't need the same notation for the whole process, which is typically today. So if you have aspects that have high variability, where you don't know in advance what is your control flow, or really don't care because you have dependencies you need to adhere to, then you may write this stuff in DCR graphs or CMMN. While if you have highly regulated processes and your auditor only knows BPMN, or those are processes where BPMN is the best modeling notation, then you do it that way. And you can always transparently deviate from those structured processes, since all subprocess instances share the same context as the parent case. If you want to change artifacts, you do it in the parent. If you need ad hoc activities that you haven't planned in advance, you do it in the case as well. And those are performed within the same parent activity stream, and those are also visible to auditors. So the basic idea is also that end users can create simple automation themselves to get to know BPM methods, or to get more sophisticated over time. So the model on the right is actually what we kind of expect from starting users. You ask some questions, do some basic transformations on those variables you gathered, and generate a document, for example. For hierarchic data management, we saw that a lot of these types of projects, at least in regulated domains, show some type of hierarchies. For example, task level hierarchies you might know from most work management tools, or hierarchically managed tasks, where you have similar situation but different artifacts in this case. And also from typical BPM modeling, where you perform sub-processes of one overall process. The big question we had in this case, where it's also flexible, how do you share information across those levels? And we derived 4 different types of dependencies here, which you see on the right. First of all, it's important, if you are flexible, where do you define this sort of dependency? For example, in the parent, you can say, please take all this information from that attribute in each and every subcase or subprocess, or how do I get this information from below, for example, gather all tasks. And in the child, you can also say, I want this attribute, which the other subcases might not need, but I want it here in my scope as well, and synchronize it with that. Or I want to export my result, which I had made during this process, to above. And for that, we have flexible master data via entity attribute value schemata, where you add to each artifact and to each case which type of attributes you actually need here. We also added tabbing, ordering, references, and so on, where you can play a little bit with how you manage your data. And we added fixed data schemata you can create. With fixed, we mean those are still extensible. If you need an additional attribute, you won't get that much visual support for that, but you can add all the attributes you need. For the master data dependencies, we provide inheritance and import dependencies. For inheritance, you can argue whether this is the right term. I don't know yet. I use it for now until I find a better one. But the basic idea is still the same. And also for task aggregation, we have it for this type of artifact as well. So let's switch to the actual system. Feel free to provide your own examples if you wish. Otherwise, I'll do my story. And what I can now say, since my time was management was worse prior to that, is in the background, Opportunity is actually a complex event processing system with lots of publish subscribe on every level. It's already multilingual, and here you may see it. On the right side, you have different status types we can add. On the left side, we have our case view with hierarchy cases and different states attached to them. If I just now add some artifact, you can directly see it. This type of state is now available to all cases. All the case states can be modeled by yourself. All the task states can be modeled. Each and every part that has some domain dependence is actually configurable. So we try to tackle adaptive case management really in this part. And for now, we add a new case for a research project. Let's call this one Pertunity ACM. It's a research proposal or something, even though it already exists. You can have parent cases, I'll show that later. And you can also organize different artifacts, for example, correspondence for CRM functionality or arbitrary data objects if you need them here. So this stuff is for user access control. Let's start with this one. For each case, you have many ad hoc artifacts you may create if you want them. For example, you can add your stakeholders as you wish. Let's say I'm a programmer now. And you can also create tasks with different types of views for how you do it on your mobile phone as a list, as a Kanban board, or by categories. It's empty for now, but we can also add some artifact, like it's typically for groupware. We have a calendar. The view of the calendar is mostly your mobile phone in terms of integration, and you can also add arbitrary other stuff. Let's start with the processes. If you're not sure how to perform a process that is typical to some degree, you can actually model it in advance, like this one. Here you see one of those sub-process instances I talked about. It has two activities that have here a form attached, and here it's just I did this one and document it. Those three tasks you can also see in the Kanban board I show a little bit afterwards. And let's start with getting management approval first. You see in the activity stream that this has already been performed. This is just documentation on this part, but you can also gather data out of this process. For example, tracking and tracing app, which we want to start, or whatever. Hopefully not. And let's take Sophia as a coordinator. We have this data we gathered now in our scope and can use it, for example, for document templates or play around with it afterwards. So this is not fixed. Also, this process has no further step here, but these three activities were modeled as typical tasks you also want to see in your Kanban board or your mobile phone. So let's switch to that. Here are those three tasks that are attached to the process. You can also add different ones yourself, whatever. You can work on these directly. You may assign tasks first. Let's also let that to Sophia, or change priorities or whatever. And you can use those tasks also like you would with normal tasks you create in groupware. So you may want to add some nodes. You may want to connect it to other artifacts you have. And regardless of what you actually do with this task, it has already been finalized, and this went directly into the process management engine, where you see all those tasks have been performed, and this process is finished for now. So let's see something else. We have one sub-process instance here, but you can have an arbitrary amount of it. It wouldn't be that much sensible if you have this one again, since this is for initiating ones, you still can have it. And you also can add different other models. You can perform them at a different speed. For example, we could go further here. And each of those sub-processes has its own data entries. Some of them are filled, and each its own state, which is visible here. You can also create such simple processes yourself. I only do a very small one here, just to check how easy it is to deploy this stuff. Doesn't make that much sense now what I write, but only that it works so fast in this regard. And give it a test name or something. So this is now already available. In these views, you also see a few KPIs about it. So we only changed this one once. There's no running instance yet. Here we have 2 running instances. We already started. One of those is completed. Oh, there were 3 instances in total. And yes, let's go back to this one case. And we could directly start the process we already deployed and also finish it here. So regardless of how little sense this single process makes, you have different types of steps, different types of sub-processes, and this already works. Let's see into details. You also saw here that you have an activity stream for each process. You may also have seen that you have an activity stream for each artifact. On case level, those are aggregated and can get to a larger volume. And you can also have an overview of all the cases that are visible to you in the home screen. So let's go to one part I missed in the first time I gave this demo. We have sub-processes and sub-cases, and for sub-cases I can show it as well. Let's make this research project a little bit larger, so it needs a keynote for something. We give it the parent case of this new one we created. I pre-filled the stuff, and now we have this project structure. Let's add a few tasks of however useful they might be. And we see the project structure. Let's go to back to the parent case, and in this task structure we can display all the tasks of sub-processes and how they stand as well. So we can have it collected all here. And we can also relate these processes, these tasks to artifacts of the parent case if we wish, which would be this document again, for example. What you also see is typically these group artifacts are scattered across many systems. Now that we have all of them in here, you can connect stuff that would take lots of nodes, like this is in Trello or something. You can all have it here, and you can also use this stuff for automation or arbitrary attributes you may add, like working hours or something, whatever you need. The data management and task management depends on the workflows you want to actually achieve. So next to sub-processes, we also have small automation in form of templates. You can also create, this is a small templating language we created that is visual. And all of those templates can be multilingual, as well as we plan and want to implement it for processes. And yeah, I guess now you saw most of what we can perform. So I'm happy for your questions.
Indeed, thanks very much. So we let the presentation go a bit longer than expected, but I mean, the system is kind of large, so it was nice to have a broader view on the capabilities it provides. So yes, indeed. So any questions from the audience? Again, feel free to just turn on the mic and ask, or write down. Hey, there we are. Hi, Hugo, please.
Thanks, Johannes. Thank you very much. It was a big system, so I could only spot some of the key parts. But I was interested on this because you show that you can create both the imperative process models and declarative process models. And how do you link them? Like, is there any kind of inter-process communication between them, or how do you do it with that?
Currently, there only is communication via cases, but actually that's intentional since we only look into some aspects of it. So we would link that by, for example, if you have travel expense sub-process and travel, I don't know, this one where you get your acceptance from a professor or whatever. And you would link them by creating in the second one that you attend this BPM conference to get the location, to get who accepted it, and so on. And if these attributes are available in the expense report, you don't need to ask the user. So this type of dependency we have, but that we don't directly connect those processes is intentional. And the only stuff we actually do to connect them is by allowing to start sub-process instances out of them. This is not yet working that good in the actual implementation, but this is how they get connected. But also this is how most BPM systems connect them, just by starting sub-processes.
No, but it makes a lot of sense. Thank you.
Thank you indeed. All right, so I thank the audience, I thank the presenters, everyone in this room, and of course Bedilia for her precious support. This basically concludes this room for the presentation of the demos. Were all very interesting. It's fabulous to see how BPM is routing its implementation and facilities into very many projects spanning over so many perspectives. Very lovely. Great to see already the how to say, not only the rewatch the videos that we recorded today, but also the ones that were published on Vimeo for the moment and will be made public right after the end of the conference or even during the conference. Thanks everyone again. Big applause to you, although just hearable from here, from this side, but I think everyone agrees on that, I'm sure. And yeah, thanks everyone. And yeah, see you soon. Coffee time. Bye-bye.
Bye. Thank you, Claudio.
Thank you.